Okay, I'm going to go on to the second set, which is the product quotient and chain rules review problems. And the first problem is to differentiate the function y is equal to x squared plus 4x plus 3 over the square root of x. And we have a basic quotient rule problem here. So we would say y prime is equal to low, which is x to the 1/2. Now you don't need to say x to the negative 1/2. It's the function that is in the denominator. It's not the 1 over square root of x, but it's x to the 1/2 power. So it's low, d high. The derivative of the numerator is 2x plus 4. Then minus high, d low. So it's x squared plus 4x plus 3 times the derivative of the square root of x, which is 1/2 x to the negative 1/2. That's going to be all over square root of x squared, which is just x. Alright, so this should be simplified a little bit. Let's see what we can do with it. Alright, so rewriting it, I get square root of x times 2x plus 4 minus x squared plus 4x plus 3 over 2 square root of x, and that's all divided by x. The easiest thing to do here would be to multiply top and bottom by the square root of x, or by 2 square root of x. And that would leave me, I'd have to distribute this out, so you have to be a little bit careful with this. Well, 2 square root of x times square root of x over here is going to give me 2x times 2x plus 4, and then the 2x is going to cancel with the second term completely, and I'm going to get minus the quantity x squared plus 4x plus 3. And so you have to be careful there to put that in parentheses. And then in the denominator, I'm going to have 2x squared root of x. Now, once again, I should do some simplification on the left side and combine some like terms in the numerator. And I get 4x squared plus 8x minus x squared minus 4x and then minus 3, all over 2x square root of x. And I would prefer to write the x times square root of x as, since square root of x is to the 1/2 power, x is to the 2/2 power. Sorry about that. Once again, since x square root of x is x to the 1/2, and x can be written as x to the 2/2, then when I multiply two numbers with the same base, I add their exponents. That becomes x to the 3/2. And so my denominator is 2x to the 3/2. Alright, just cleaning up the numerator, I have 4x squared minus x squared, so that's 3x squared. Then I have 8x minus 4x, so that's 4x. And finally minus 3, all over 2x to the 3/2. Now, again, that's a lot of work at the end of the problem after we did all of the difficult differentiation to begin with. But the answer is pretty concise and compact there. So I would like you to think about doing that stuff. It's good for your algebraic skills, which you're always going to need, that you continue to try to simplify it as much as possible. Now, I don't know if that 3x squared plus 4x minus 3 factors into something. I'm going to assume that it doesn't. But if I could factor that in addition, that would be all the better. But this is good enough for me right here. All right, so this is going to be the first problem, and I think I'm going to stop the first video at this point, and we'll start with number 2 in just a second, on the second video, I should say. Okay, so that's the final answer for the first one. If you stop somewhere along the way above that and you did all the differentiation correct, that's really the most, that's basically the most important thing, but you can see the big difference in the way that this original state of it looked and the final state there. There is a big difference, and it's worth the time to do some of that stuff. Okay, we'll continue on the next video.